Hello and welcome to Vodcast 6.3. In this Vodcast, we will take a look at the layered structure of Earth's interior. As a forewarning, you'll find multiple quiz and test questions that come from this particular Vodcast, so be sure you prepare accordingly. We know what we know about what's inside Earth based on our study of seismic waves. First of all, it should be noted that Earth has distinct layers. The heaviest material will be at the center, and the lightest material will be towards the top. So if you start at the center, we have a really heavy, dense iron core. You'll find a rocky mantle and crust, a water ocean, and then a gaseous atmosphere. Another important concept to consider about Earth's interior is that it's a very dynamic arena. The mantle and the crust are in motion. And last chapter, when we discussed plate tectonics, that was one of the key features we really emphasized. But it's also important to know that materials recycled from the surface to the deep interior, and that occurs through convection, which is another concept that we have overviewed previously. Let's start with the structured layer that we're all most familiar with, and that's Earth's crust. Earth's crust is the outermost layer, it's the layer that we walk on, and the crust is the thinnest of all Earth layers. There are two classifications for our rocky crust. There's oceanic crust and there's continental crust. Oceanic crust is composed primarily of basalt rock, whereas the continental crust is made up of a variety of rock types. A couple other things to note about the differences between oceanic and continental crust are that the continental crust is much thicker than the oceanic crust, and the continental crust is also less dense than the oceanic crust. Now let's shift our attention to Earth's mantle, and the mantle is the largest layer of Earth's interior. The mantle is a solid layer, and it makes up 82% of Earth's volume. At this point, we're going to consider two segments of Earth's interior that you probably already know, but they're extremely important and worth re-emphasizing. The lithosphere is defined to be the uppermost mantle in the crust, and the lithosphere is the cool, brittle, rigid outer layer of Earth. When we talked about plate tectonics, it was these chunks of lithosphere that served as the plates. Now just below the lithosphere, we have the asthenosphere. The asthenosphere literally means the weak sphere. And it's important to note that the asthenosphere is the hot, weak layer in Earth's mantle. Now the lower layer of the mantle, which makes up the majority of the volume of the mantle, is also hot like the asthenosphere. But the lower mantle is strong because of extremely high pressure. The asthenosphere is the weak sphere because pressure increases with depth, and the asthenosphere is not a layer that's particularly deep into Earth's interior. Remember, conceptually speaking, the lithosphere kind of floats atop the asthenosphere, and that's what allows the plates to move. Let's continue our journey towards the center of our planet. Earth's core is predominantly an iron-nickel alloy, and with a density of about 10 grams per cubic centimeter, the core is over 3 times as dense as Earth's crust. Now, a very important note to make is that the outer core is in a liquid state. It literally is sloshing liquid metal. We know that the outer core is liquid iron because we've studied seismic waves. And in our previous vodcast, you may remember me mentioning that P waves can travel through solids, liquids, and gases, but S waves are only capable of traveling through solids. Well, S waves are not capable of traveling through the outer core. And that fact, along with a lot of other science, has helped scientists conclude that the outer core is a liquid layer. One extremely important benefit of the outer core being liquid metal is the creation of Earth's magnetic field. We have this enormous magnetic field that surrounds our planet and blankets us from some very harmful solar radiation. And that magnetic field arises because of the sloshing of liquid metal in the outer core. Now the inner core is solid, unlike the outer core. And the inner core is solid iron that's under extremely high pressure. Okay, that concludes this video podcast. Hopefully this video has helped you develop an understanding of Earth's layered structure. In our next podcast, I will overview some of the different types of faults.